Okay, let's get to it. Hello, my tiny intimate crowd. I know all of you guys want to go watch the robot after Rakesh's performance yesterday. There's another robot in the house, so let's get through this as fast as we can. I had to make an unscheduled change to my topic. Instead of talking about anything regarding JavaScript, I actually want to talk about a movie. I want to talk about How to Train Your Dragon is the best movie ever made. Anybody agreeing with me? No? Okay, yeah, that's not the topic anyway. Bangalore JS started a little while ago, and this is a talk that I actually gave over there. Another participant from there is right there, from Hasgeek. Hi. And it was great. It was a tiny audience, and we were encouraged to come and talk about stuff that we have actually learned that's not in the course of our work or whatever it is, stuff that's happening in the industry. And what I really wanted to talk about was animations. Animations to the regular JavaScript developer nowadays is very limited. You might just use jQuery and say move it from a position X to position Y, position A to position B, and so on and so forth. And nobody really understands what science is behind it. And there's a lot of cool stuff that can happen in JavaScript that you can use JavaScript to emulate cooler animation engines like Flash or maybe iOS. My name is Sunil Pai, and I work at Yahoo, which has a metric shit ton of JavaScript on its hands. Not a lot of animation work that goes on there, but I work on the Maps team since about December last year, and we've been wanting to make it a little cooler because of the big large elephant in the room, so to speak. So yeah, fair warning, I'm not an expert in the topic. This isn't really my thing. If you wanted to talk to me, I'll talk to you like about build systems. That's the thing I'm interested in really, but this is what I like doing on site, and this is how I learn new things. The question then is like, why did I want to do it? I'm a big believer that the user experience is essentially what seals it for your user or for your customer or whoever you're trying to pitch your product to. You could have the best data in the world and a crappy interface won't save you from it. There are enough people who, for example, there are enough people who say that Nokia Maps has much better data than Google Maps. There are enough people, and they give you examples. But the reason that you go back to maps.google.com is because of the user experience, because it's nice, it clicks around, and you know where you can find stuff. Animations, I feel, are a very important part of this. I believe, for example, animations are one of the main reasons that this product is selling millions, about 200 million iOS devices on the market right now, I think, ever since they launched in 2007. So you ask yourself, one good reason is, oh, it'll make the customer want to buy it more and all. I think a much more base reason for this is that as a developer, you're the one who has to be caring about what the user experience of your product is. You're not out there. You have to start treating your product like you're a craftsman and not just a manual laborer who's building a brick wall. You want it to be a piece of art. You want your product to convey exactly what you want for the user to understand. Something as simple as slide to unlock. Very popular example. It's very clear, and if you guys can take out your iPhones or even on Android, and you'll actually see this, the moment that you start holding it and dragging it around, it doesn't really follow it exactly. Like if you move it a little fast, you'll see that it moves to the edges and back and forth. This is something really smart. This behavior is there all across iOS. Every time you're browsing a web page or closing an app, if you notice on iOS, nothing blinks. When you're closing an app, it actually like shrinks down and fades away. When you're trying to open an app, it actually bumps out at you. This apparently was a Steve Jobs diktat. He's like, on iOS, I do not want anything to pop. Everything has to be smooth. Everything has to seem natural. And that's the kind of behavior you want from the app that you're building. The fact that you have a button means that you want it to behave like a button. Somebody clicks on it, it becomes a little concave, then bounces back up. You hover over a link, it reacts a little way to tell people, yeah, you can click on me, and so on and so forth. So yeah, basically, generally, essentially, favorite developer words. I think I saw a tweet yesterday for JSFoo. It said basically ad infinitum. But yes, the basic deal about animation is you can say that you want to take an object from a particular state. It could be an X and Y top and left position on your page, or the color you want to move it from green to blue. And in a regulated way, you want it to transition over to that state. So a little piece of text that's 12px, you want to expand it and make it 16px. You don't jump all the way. You go 12px, 12.5px, 13px, and so on until you reach your target. So let's look at one very basic, animation. I remember what So basic animation, you have a little cube, little box, and you want to move it all the way to the right side. So you click on it. If you noticed it wasn't very smooth, there's a reason for that. Turns out that, so what you would do when you are making an animation like this, if you're writing your own code and not using jQuery, is you'd say, oh, check the ad flow, that's not on my slides. Okay, anyway, never mind. So what you would do is you'd say, okay, fine, there are like about 300 pixels and I need to traverse it in about 3 seconds. So 100 pixels every second. Okay, and you assume that you want a frame rate of about 16 frames per second. That's the 60 frames per second. So that's 1000 milliseconds divided by 60, you'd get about 16 milliseconds. The airflow wasn't checked. Anyway, no, so I'll go on. So you assume that you'll write a logic that says, okay, fine, every 16 milliseconds, so you'll say set interval for 16 milliseconds, move it ahead by so-and-so pixels. You've done a little math that calculates how it goes ahead. Major problem with this in JavaScript in browsers, or frankly, even on Node, I've tried this. Timers in JavaScript suck. You say set interval for 10 milliseconds, it'll probably come back after 12. If you're actually trying to do some data crunching in the middle, you're trying to calculate positions and all that, it'll come back after 20. And by the end of it, your animation is janking all over the place because your assumptions about the calculation have been wrong. And it's the part I will get back to the slides, but I'll tell you anyway. Whatever. So yeah, so trying to use set interval for such a thing. I have a slide here which says set interval sucks, not Hitachi. Although I'm sure they're a good brand. Airflow notwithstanding. Moving back to it. So set interval sucks. So thankfully, there's a very easy solution for, well, not easy, it's what we have. What you say is you run a cycle anyway. Run it, you say 1000 by 60, run it every 16 milliseconds anyway. But you mark what your starting point is. You say new date object dot get time and you'll find a particular millisecond time. Then after every cycle, you actually check how much time has passed. So you'll know that 12 milliseconds have passed instead of 16, or maybe 25 milliseconds have passed. Then you do your calculation again at that point of time. You say, okay, now that 25 milliseconds have passed, I actually have to move it so and so. Oh, it says set interval sucks. Okay, we're back. So yeah, the word for this is actually tweens. In other words, in between stuff. I believe this terminology comes from the Flash world, but it might come from before that as well, I'm not sure. But it's something that I picked up from Flash. They're called tweens. You want to tween your animation. So when somebody says that to you, if they're not abusing you, it means that you're going to do this sort of thing. So let's see a demo of what the same animation would look like if I was tweening it. Oh, okay. So yeah, so you'll see that, well, it's still a little janky, but it's definitely slightly better than the previous one, which is good. And that's a slightly old laptop, so I'll just blame it on that. I'll blame Apple. But yeah, now that you know this, you can base all your animations on tweens, which is to say, you tween all the things. You stop using set interval as a reliable method. That's point number one, okay? You start tweening. Code for all of this is available. I won't be showing any code here, but it's all available on GitHub and all that stuff. Next thing that we talk about is easing. The most naive way of saying how an animation works is to say, that it moves linearly. That's called linear easing, as an easing equation. Feel free to Google it, lots of literature on the topic. But it turns out that natural objects, at least in the real world, nothing moves in a linear fashion. You take a little ball and you roll it on the ground. It starts off a little fast, but let's say because of friction of the ground or air resistance or weight or gravity or whatever, it starts slowing down. Probably with a sinusoidal style easing down. There are a bunch of popular easing equations, and you've probably seen these in use in a bunch of places. The first one is it's called an ease inside. I'm sorry you can't see the labels, but the idea is that it starts off a little slowly and speeds up towards the end. This is an ease out sense. Starts fast and slows down during the end. There are some fun ones for like elastic. You've probably seen objects where they go past the targets, come back like a little bit elastic or spring or whatever it is. So the equations for that are regulated by these. These are very simple f of x, y functions that you can easily incorporate into your animation. But the idea is that you should know that you try to figure out what the appropriate easing for your object is. How is your link going to glow when you hover over it? For you right now, you're going to say, okay, we put a CSS3 transition between this state and that state. You say a transition for the color and it tries that. Try to figure out, if you're using JavaScript, if you're writing your own timers, what equation you're going to use. So that is what easing is all about. That's step number 2 when you're doing animations. You try to make sure that you get the appropriate animation, not just a linear move one object to another. Step number 3 is, this came out last year. It's called the Request Animation Frame Spec, part of HTML5. So it turns out in animations, there's a very, like I told you, you do it in a particular way. You run one step, change the state of all the objects that are being animated, run another step, move a little bit, little bit, little bit. So browser makers realized that that is the common animation loop. And they decided to make it easier for users to use it by tying it into the browser. Since the browser is already in charge of the render process and a whole bunch of other things on a low level, they can expose something as a timer that is not just slightly more reliable, but mostly they say, fine, as a browser, every so and so milliseconds we refresh our page, let's match your animation steps to match us. Fine? And that obviously makes it a little more efficient. You make all your changes in one step instead of, for example, using set interval where one animation might be blocking another and your thing gets screwed up. So Paul Irish wrote one of the pioneering steps on it, how to write a shim for browsers and how to fall back to set interval when it's not available in the browser. And it's pretty good. I think pretty much every animation engine now is picking this up, which is that's cool. And a really good use case for this is in mobile, where really bad power constraints, the processor isn't great and all. You try to get as much help from the browser as you can, and Request Animation Frame helps. There are a bunch of other stuff, of course, like CSS 3D Translate, which becomes hardware accelerated and all that jazz. But as far as you're concerned right now, as a JS animator, Request Animation Frame, that's point number 3. Moving on. So what are dynamic tweens? Dynamic tweens still aren't really mainstream in the JavaScript animation world. When I was making this talk, I didn't really find it across all the popular ones. For example, I think at the time I was looking at the 1.6 jQuery code and they were still using set interval. The guys who, Thomas Fuchs, if you guys have used an animation library in the past called Scriptaculous, he was very hardcore on trying to figure out tweens and all that jazz. But even he didn't. Don't click execute. Anyway, so I'll tell you more. Yeah, so dynamic tweens, however, the deal with regular tweens or regular animations is that you think that you know the duration of the animation in advance. You will say, take this animation, take this animation and run it for 0.5 seconds. That's a usual parameter in everything, or they default to 1 second for all animations. But there are some animations that do not have a set period. We'll go back to slide unlock. You know, the thing is animating under your hand, but with no concept of duration or time. It's just doing it on a dynamic nature with what the state of your thumb is at the given point of time. It's a new project. No, it's okay. I've accepted that at my Hasgeek events this happens, and I just talk to the crowd. I've learned in the past, while the projector comes on, and I will never have a public audience to do this again. You guys know how Charlie Chaplin flicks his heels? You know, he does the thing. I actually learned how to do that. Thank you. Anyway, so dynamic tweens are about that the duration isn't part of the thing anymore. Speed probably is how fast you want the object to be moving based on your easing equations or what the perceived weight of the object is. When you're doing a browser page scrolling on your touchscreen device, it feels like the page has weight. That's why inertia works, and if you flick it just a little bit or a lot, these are apparently patented algorithms now, but you know, screw Apple. I wanted to say that you can pull out your phones and you can see this in action again. A good place is obviously the browser page at this point of time, especially at the very end where it starts doing the little rubber band bouncing. Oh, cracked iPhone screen. I joined that club as well. But yeah, if you see it, it doesn't really have a calculated animation at that point of time. It starts that animation as you let the finger go, and then it tries to figure out how it should bounce back to the thing. And it's all dynamic. I'm pretty sure it's all dynamic. This was something Android got wrong in the beginning, and all the Apple fans came out and said, oh, our physics are better and all that jazz. So how do you do dynamic tweening? What is the math behind it? The simplest base explanation for it is based on this concept called Xenos Paradox. Anybody here heard about this? Very popular philosophical argument thing where, let me give you like a short version of a short story just to get this on. You guys have heard about the rabbit and the tortoise story, of course. Okay, so the story is that a rabbit goes to sleep, tortoise comes and moves ahead by about say 100 meters, right? And the rabbit wakes up. The rabbit wakes up and says, okay, now I got to catch up to the tortoise. let's say it takes about a second per meter for whatever reason, okay? So it'll take him about 100 seconds to reach where the rabbit is at that point, where the tortoise is at that point. Let's say the tortoise is moving at 1/10 the speed the rabbit is. So by the time the rabbit crosses 100 meters, the tortoise has reached 10 meters. Then to get 10 meters and the tortoise has reached another meter. So by that logic, you would think that the rabbit never actually reaches the tortoise and and that the tortoise would win, or so on and so forth. But anyway, there's some math in that that's actually interesting in our case for our animations. The idea is that instead of moving linearly towards a particular place, you can just move for every cycle of your animation, you move a step of the way. You move a fraction of the way. So the idea is that if you're going to reach the end there, you'll traverse about, let's say half. In this case, it's about half, but you traverse half in first cycle, then you traverse half in that, and so on and so forth. And if you think about it, this starts seeming very similar to the elastic behavior on your phone, where it starts off really fast and starts slowing down near the end. Very useful algorithm, and buttload of demos to show you for this. This is part of a little side project that I made in YUI, little animation library. It's in YUI, but the code is available. You can, feel free to interrupt me and tell me I'm wrong, or my heel clicking skills are awesome. Anyway, so this is part of a little animation library that I wrote called Pizza, just to explain dynamic tweening. So here we go on that. If the airflow thing comes again, oh, okay, nothing's. Okay. It's okay, that's fine, it's fine. It's good. Yeah, that's okay. So let's start with something basic. Okay, drag and drop. Most simplest, one very common dynamic animation case. So base drag and drop animations everywhere follow a very standard pattern. The moment you click your mouse, the object starts following whatever the X and Y positions are. Okay, you move to X, the thing immediately snaps to it. That doesn't feel very natural, but let's see what it looks like with tweening. I've put a little high threshold here, so it might not be that clear, but keep an eye on the mouse. The idea is that I move really fast, but it springs to it. Do you see it? Like, it's not following the mouse exactly, but it's coming around. Go back to your phone browsers now and see the inertia. It doesn't really, or slide to unlock. It doesn't really follow the mouse, but it tries to follow it. It uses the Xenos algorithm that I just showed you. I'm using a fraction of about 80–85%. I don't remember exactly, but that is the deal. It moves about. It starts moving in those steps, and it starts feeling a little clearer. I did a little user testing inside the company, secret, to see how well this behaves with a bunch of users. Oh, okay, it's all demos now, no worries. So we did a bunch of use cases, and it actually turned out to be quite nice. They actually appreciated it, and they said it feels nicer. They said it feels smoother. There's no reason, the browser isn't faster or anything, but they actually feel like it's smoother and a little more natural. Okay, next demo. I implemented a bunch of nice, well, nice to me, use cases to show you. This is one that I did for a slideshow. It's a little photo slideshow that I had seen on a website a while ago, and I figured I can do it in JavaScript and not Flash. The idea is that you'll probably show all your little screenshots over here. There's a little math which says if the mouse is down here, then put it up there. But it's following the same tweening algorithm. This is about 7 lines of JavaScript to get this. I put a little thing, let's say this is the photo you want to see, click it and it'll show up here. Seems pretty nice. So that is my slideshow implementation, and it's nice, it feels a little natural. Has anyone here ever used the Picasa desktop app? No? No, they had that, but more importantly, they had those cool scroll bars. They weren't regular scroll bars. You pulled it and it kept, scrolling down and so on and so forth. So I did a little implementation of that in JavaScript. Let's say you have a bunch of that. Same algorithm, guys, not a lot of code. You move it and it keeps moving along. I've capped a max speed for it. You find a place that you actually like. So yeah, this is my Picasa scroll bar and implementation with dynamic tweening that worked. This is the one that will apparently get me into legal trouble. I implemented the rubber banding that browsers have, that only iOS has, and that's patent 381 or 915, I'm not sure. The idea is that, let's say that this is your viewport, this is where your this is your phone window, and this is the size of the web page. So yeah, you can still drag it around, and the moment it starts reaching the very end, it starts rubber banding. So you can leave it and it bounces back up. And it's nice. And mind you, I also using the same logic, I implemented a little bit of inertia, so you can flick it around and it goes around. But yeah, it still sticks to the rubber banding boundary. that's pretty cool as well. Okay. Quickly show you another demo of what I was talking about. This is slide to unlock. It's a little grayer here. But the same thing, like it's trying to follow it. If it doesn't reach the very end, it'll just snap back. But the moment it reaches the very end, stops and it'll probably fade out and start your very highly patentable OS. I'm very mad at Apple. This is something I made. I never got to finish it, but the idea is that here the object would snap to a grid. This is like when you're trying to sort objects. So you might see a little outline of the actual object that I'm drawing, but I'm actually snapping it to, I think, 50px boundaries. And that looks nice. You can take a little slideshow thing and move it around. And there's no fresh animation object that you have to make every time you want to move it. You just say, just keep snapping it to the closest grid that you have, and that worked as well. Moving on, let me show you some other demos that I made. Now that I have about 7 minutes left. Wait, let's get my mouse there. I work in maps and I try to wank about it, but I wanted to get I don't like the drag and drop interface of a map, so I wanted something that was a little more fluid. So I did the same thing that I did for the slideshow, is that you move your mouse around and it actually scans. I have a little mini map there to help you. And this felt a little nice as well. Mind you, I'm not clicking anything, I'm just moving the mouse around. The idea is that if you do find something that you're interested in, let's say India, you would click that and it would focus to that and then do that animation. No, not too bad. This I just did for fun, and since I have a camera recording it, I'm going to show it to you anyway. I call this Tron worms because I like Tron. Little animation just with divs. This isn't SVG, canvas, anything. But if you can get a little math into it, make it a little, make it a little optimized, it actually looks really nice. I wanted to make this as a landing page for another website I made years ago. But yeah, those are my Tron worms. That's okay. I have another demo that uses SVG. This is an actual clock that is sold by the Russian design firm Art Lebedev. They also make the transformer keyboard, if I'm right. But this is an actual clock with physical pieces. And I was like, listen, I can do that. And I was also experimenting with Raphael.js. This is the Svg Animation Library. Implemented a few algorithms there as well. And I managed to make a little thing with real clock arms spelling out numbers. That worked as well. Moving on, this is one of my favorite ones because I did this as a challenge that somebody made me, that you can't emulate water in JavaScript, you have to use Flash. I took on that challenge, and the idea is that that's the ocean, and you move across it and it does little things. That's SVG, by the way. It's not divs or anything, but this is all JavaScript, and it's pretty smooth, fairly accurate. I figure on a stronger machine you would increase the number of points here and all that, but hey, I have a little boat there and drown words in it. Not too bad. Okay, thank you. Quickly. Okay. Thanks. I stole code, man. I just ported ActionScript to JavaScript. Thanks for the applause for that. This is a site that's still live. It's one of my previous employers, the design firm who do the future group work all over the place. They have a massive portfolio of clients, and they wanted to show some easy way to categorize it. Now, one very easy way is, and just like designers would, they have to name their categories as thought and social, and who names a category thought? Everything is thought. But the idea is that I could have clicked on it and shown just those things, but I wanted a nice animation in the place, so I do something like this, like it shows this. You can move back, and that takes it all the way back and brings those out. You can probably click on one, and it starts showing little screenshots, assuming that it loads. It would show little screenshots here. And that's nice, and then you can move on to other pages using this. So by itself, those pages without JavaScript, they would load regular pages, just those bits and those icons. But with JavaScript at our hand, we can actually make the user feel like he's taking bits out of a huge portfolio and seeing them from there. Quickly, I actually wanted to talk about this for a while, but Adobe just launched a CSS Filter Spec, if you guys have been following this, and it's absolutely insane. The idea is that now you'll be able to use OpenGL's shaders for CSS elements. I didn't have time to build a demo for this, but I quickly want to show you the video of what is possible. That's they're applying grayscale and color stuff. Idea is that you will pass the shader in your CSS. You will tell them that point to this file, and if you guys haven't seen this before, this is what they're doing with CSS. Skews and folding elements and all that stuff. Over the next year or two, all of us are going to have to learn how to write shaders. Look at that stuff, look at it. I mean, that's absolutely mental. and with an industry standard. They've not invented a new language or anything. Technically not JavaScript, obviously it's a shader language, but so simple. I think there will now be a breed of demos over the next year which utilize CSS filters and do Mac demos. Quickly back to this. A quick side note. I of course said that I'm doing this only with HTML elements, not SVG and stuff. So there are a bunch of ways that you can take a regular div and make it into shapes. I have a couple of links here. Feel free to take them from when you're done. I given a link to the CSS shaders video also that I just passed on. If I have time, I want to quickly show you another demo. Do I have time? No, like 1 minute? Say yes. Huh? 3 minutes? 3 minutes is good. Okay. This is purely CSS. I try to build a 3D isometric world using just JavaScript and divs and CSS. A little bit of shading, I get the faces changing around. I have a little logic for layering, but that looks pretty neat. It was supposed to become a lot of other things that Kiran is staring at me for. This was supposed to be part of stuff we were working on.
This was supposed to be the JS4 website.
This was supposed to be on the JS4 website. We never got that, but this was part of the animation. Very arbitrary blocks moving around a nice little 3D plane. And that's about isometric stuff. Quickly, questions before my time runs out. Any questions?
First question, do you have your code up there on GitHub? So
actually, I think I have it in a media file, zip file somewhere, but I'll put it on GitHub tonight, I promise, I swear.
Make sure that we are stealing it. Okay?
Go for it, man. I think I heard, somebody was telling me that somebody took my code and made a presentation at Google India talk, something. I mean, that's nice. It's nice to be stolen from. It's a good problem to have. Questions? I ran through it, I'm sorry, but hey, it was demos, man.
Are you on Facebook?
No, I'm not on Facebook. Sorry, bro. I'll give you a friend request that is like, I'll give you an SMS or something. You can keep my phone number if you want. But no, I'm not on Facebook. Nobody? Okay, everybody's gonna head for the robot right now. Thank you for coming and seeing the stuff that I learned about.